Welcome to today's lecture on dividing fractions. I'm Drew Collip. In today's lecture, we'll examine how to divide fractions properly. Before we can divide fractions, we must understand how to take the reciprocal of a fraction. This can be a challenge for values that are mixed numbers. Let's review. So here's the process to find the reciprocal of a number or fraction. Step number 1, if it's a fraction, just flip it over. The numerator becomes the denominator and the denominator becomes the numerator, like in example 6a. In this case here, we see 3 over 5. So we bring that down to the bottom, and the 5 comes up to the top. Please note, don't write equals to. These values are not equal to each other. Instead, what you can write is perhaps an arrow to indicate it's transitioned over to a reciprocal. Now, if you have a whole number, all we do is we divide by 1 first, and then we flip it. This comes up, this comes down. 1 over 42. Now, the tricky part sometimes is converting the mixed numbers. The first thing you must do, you must convert it to an improper fraction. So we take the whole number, we multiply the denominator, and then we add to it the numerator. We then place it over the original denominator. In this case here, 1 times 8 is 8, plus 7 is 15. 15 over 8. Now we take the reciprocal. This comes up and this comes down, and we get 8 over 15 as the reciprocal of 1 and 7 over 8. Please be careful of this. Many a student has said, oh, this is easy, sir. This is just 1 and 8 over 7. Wrong. You can't do it that way. Notice these values. 1 and 8 over 7, that would be what? 7, 15 over 7. Not even close to 8 over 15. So please don't do this. Now that we understand how to take the reciprocal of fractions, whole numbers, and mixed numbers, now we just include the rules we know for multiplying fractions, and that's all the skills we need to do these problems. Now let's examine actually dividing fractions. So here's a process. As always, I like to have a process written down. Step number 1, change mixed numbers into improper fractions. Please do that. Do not keep them as mixed numbers. Change whole numbers into fractions by dividing by 1. Now what we do is we look for the value that we're dividing. That is the fraction or the value following the division sign. We now take the reciprocal of that value that comes after the division sign. We then change the division sign to a multiplication sign. We multiply the fractions, and then we simplify where possible. Let's try 7a right now. So here, this is the value following the division sign. So we're going to take the reciprocal of that. This then becomes 2 over 5 times 4 over 3. We then multiply the numerators, and we multiply the denominators. 2 times 4 is 8. 5 times 3 is 15. Final answer. Cannot be simplified down any further. Let's try the next one. B. 5 over 6 divided by 7 over 8. Again, we're taking the reciprocal of the value that comes after the division sign. This becomes 5 over 6 times 8 over 7. Now we can simplify this a bit. I can take a common factor out of the 6 and the 8. One's on the top, one's on the bottom. Common factor of 2. How many times does 2 go into 6? It goes in 3 times. How many times does 2 go into 8? It goes in 4 times. So now I multiply the numerators, and I multiply the denominators. We get 5 times 4 is 20. 3 times 7 is 21. Can we simplify that any further? No, we cannot. That is our final answer. I just want to look at one thing for a second right here before we move on. If I said 4 divided by 1/2, what does that mean? It means how many times does 1/2 go into 4? How many times does 1/2 go into 1? Well, it goes in twice. How many times does 1/2 go into 4? How many 1/2s can I take out of 4? Well, I can take 8 of them. That's why this works. 4 multiplied by 2 over 1 equals 8. So hopefully you understand why we take the reciprocal and we multiply. Let's now divide a whole number and a fraction. We turned the 3 into a fraction by dividing by a denominator of 1. we take the value that comes after the division sign and we take the reciprocal. This now becomes 3 over 1. We change the division sign to a multiplication sign, and we take the reciprocal. Can we cancel anything out here? We cannot. Multiply the numerators, multiply the denominators. This becomes 15 over 2. Let's turn that into a mixed number. Well, 2 times 7 is 14, 1 remaining. So we turned our improper fraction into a mixed number. Now that was when we had our whole number in front of the division sign. Now let's see what happens when we have the whole number after the division sign. Change that whole number into a fraction by placing it over a denominator of 1. We then take the reciprocal of the value coming after the division sign. This then becomes 5 over 7. Switch the division sign to multiplication sign, 1 over 4. Can we simplify down? We cannot. So let's do our math here, our multiplication. 5 times 1 is 5. 7 times 4 is 28. Can we simplify that down now? We cannot. That is now the final answer. Let's try some practice problems. I'd like you to pause your video now, give these a try. There's A, B, C, and D. So give those a try, and today we'll take them all up. Take this opportunity to try them on your own, and then learn from any possible mistakes you made. Let's now take them up. 4 over 9 divided by 2 over 3. The value that comes after the division sign, we take the reciprocal. This is 4 over 9 multiplied by 3 over 2. Can we cancel terms out? Yes, we can. I can take a 2 out of the 4. How many times does 2 go into 4? It goes in 2 times. On the bottom, how many times does 2 go into 2? It goes in 1 time. I can also take a 3 out. How many times does 3 go into 3? 1 time. How many times does 3 go into 9? It goes in 3 times. Now we multiply our numerators and we multiply our denominators. And here we get 2 over 3. Final answer. Now if you're finding the canceling out difficult, there's no need to do that. We can do it the old way. 4 times 3 is 12. 9 times 2 is 18. The only problem is now you have to take out a common factor. In this case here, we'll take out a 6. And we'll be left with 12 divided by 6 is 2. 18 divided by 6 is 3. Same answer. Now notice, I took a 6 out. And that's what I did here. Initially, I took a 2 out of these ones, and then I took a 3 out of these ones. So I'm just doing my simplification earlier on. Any way you want to do this, it's fine. But the canceling out will make your math that much faster. Let's try B now. Please note, these are not 3 separate terms. This is 1 term. Terms are separated by addition and subtraction signs. There is none of that here. Yes, there is a negative number, negative 49, but it's still a division. So let's work that out. First value, 7 over 10, remains as is. Now we're multiplying the next value. We take the reciprocal of that value, and we change it to a multiplication sign, 5 over 3. We have another division sign. So again, we take the reciprocal and turn it into a multiplication symbol. Now, can we cancel anything out here? Yes, we can. 10 and 5, I can take 1 5 out of there. I can take 2 5s out of there. What else can I do here? I have a 7 and I have a 49. I can take 1 7 out of there. I can take minus 7 out of minus 49. And I'm not sure if you see the next one. I have a 2 here and a 2 here. So I can actually cancel 1 2 out of there and 1 2 out of there. Now I multiply 1, 1, and 1. And I multiply 1, 3, and minus 7. And in the end, I get 1 over minus 21. Can I simplify that down? I cannot. Final answer. I do want to point something out here. This is a mistake sometimes students make. 1 over minus 21. That is exactly the same as saying minus 1 over 21. Exactly the same thing as saying minus and then 1 over 21. Those all mean exactly the same thing. So please do not be confused with that. There is one negative sign. It doesn't matter if it's on the top, on the bottom, or on the outside. It all represents the same thing. Please note, however, this is not equal to, minus 1 over minus 21. Two negatives make a positive. This would be equal to 1 over 21. I just wanted to point that out. Now, perhaps you're having a hard time with all the canceling. Let's do it the original way. 7 over 10, 5 over 3 times 2 over minus 49. You can do it this way as well. Multiply the tops and multiply the bottoms. The only problem is now you're going to have some simplification to do, and you might require a calculator. 2 times 5 is 35, times 2 is 70. On the bottom here now, 10 times 3 is 30, times minus 49 is going to be minus 1,470. I can take a common factor of 10 out of the top and the bottom. Remember, that's what this means right here. This gives me 7 over 147, minus 147, sorry. Now there's a 7 on the top. I'm going to hope that 7 goes into 147. I will try that on my calculator. I'm going to type in 147 divided by 7. And I see I get a whole number, 21. So here, I can then take out 7 from the top and bottom. That's how I can check beforehand. 1 over minus 21. Same answer, just a couple extra steps along the way, and you're probably going to need your calculator. Not a big deal. You have your calculator for all assessments. I remember growing up, sometimes your teacher would say, well, you better learn this stuff because you're not going to have a calculator on you at all times. It's kind of funny now because we all have smartphones and we do have a calculator on us at all times. But in order to get good at the higher order math, you need to be able to do a lot of this stuff in your head. So don't use the calculator as a crutch because you will not be able to succeed moving forward. Let's start with Bedmus. Remember Bedmus? We start with the brackets first. What's inside the brackets? Minus 2 over 3. Okay, there's no math to do in there. Now exponents. Let's square that. This is going to be equal to minus 2 over 3 times minus 2 over 3. Then we have a fraction, and we're dividing it. Take the reciprocal and multiply it. Times 5 over 3, and then we have another fraction, and we're dividing it. Take the reciprocal of that and multiply it. Let's see what we can cancel out here now. Here we have a 2 on the top and a 4 on the bottom. How many times does 2 go into 4? 2 goes in 2 times. How many times does 2 go into 2? 1 time. Notice I can do another cancellation with this 2 and this 2 here now. How many times does 2 go into 2? 1 time. 1 time. Can we do any more canceling? We cannot. Multiply the numerators. Multiply the denominators. We then get 1 times 1 times 5 times 2 is 10. 3 times 3 times 3 times minus 1. Watch out for that minus sign right there. Minus 27. Can we simplify this down? We cannot. Final answer is 10 over minus 27. Or it could be minus 10 over positive 27. Or we could have the negative sign outside the fraction and make the whole thing negative, and then 10 over 27. All those three things all represent the same value. I do want to point something out here. Some of you might want to distribute the squared here. You could do that. It's one term. So you would distribute here and here. When you do that, however, be careful. You might say, well, this is minus 4 over 9, which gives me minus 4 over 9. And if you did that in your calculator, that is not the correct answer. Why is that? Let's go back and double check. When we distribute the squared, it has to go to all values. It means it goes on the negative as well. Negative times a negative is a positive. This gives me positive 4 over 9, which is 4 over 9. And we could replace this whole part with our positive 4 over 9. Last practice problem now. Here, let's just distribute our cubed here instead of doing, we could do 1/2 times 1/2 times 1/2, or I can just distribute, and this gives me 1 cubed over 2 cubed. Remember, I can distribute this to all the values inside because it is one term. There are no numbers separated by addition or subtraction. Fraction, we're going to flip it and multiply it. Now notice when we take the reciprocal, the negative sign does not change. This is a problem some students have. For some reason, when they take the reciprocal of a negative number, they believe it always has to become a positive number. That is not the case. If it's positive when we start, it's positive when we end. If it's negative before we take the reciprocal, it's negative after we take the reciprocal. We then have our next term, take the reciprocal of that and multiply it, 10 over minus 3. We now have 1 cubed is 1, 2 times 2 times 2 is 8, times minus 2 over 5, times 10 over minus 3. Can we simplify anything here? We sure can. I have a 5 down here and I have a 10 up there. So this becomes 1, this becomes 2. I can continue to simplify. I have an 8 and a 2. I can take a 2 out of the 8, gives me 4. That becomes a 1. I can now multiply my numerators and multiply my denominators. Here we get 1 times 1 times 2 is 2. 4 times 1 times minus 3. Let's just do 4 times 1 times 3 is going to be 12. Now let's look at the symbols here. This is a negative. This is a negative. 2 negatives. What happens in the end? It makes a positive. We can now simplify this down a bit more. Divide by 2, divide by 2. And we get 1 over 6. Final answer. Now notice, I had to divide by 2. I had to simplify it. Why? Because I missed one additional value. I could have canceled a 2 out of these values right here. I wouldn't have had to simplify at all. But it's completely fine if you miss them. Why? Because you can simplify it at the end. Let's now try some dividing of mixed numbers. The first step we have to do, convert our mixed number into an improper fraction. Do not skip this step. Many students get lazy and they try and work their way around. With subtraction of mixed numbers, you're supposed to convert to improper fractions and then do the subtraction. Sometimes, if you just keep them as mixed numbers and you know where the negative sign goes, you can work it out, you get the right answer, but not always. As a rule of thumb, when you run into a mixed number, first thing you should do, convert it to an improper fraction. Let's do that first. 2 times 4 plus 1 over 4. Divide by, I'm going to keep the division sign for now. 3 times 5 plus 2 over 5. We now get 2 times 4 is 8, plus 1 is 9. Divided by 3 times 5 is 15, plus 2 is 17 over 5. Now we have them as improper fractions. Next step. Let's take the reciprocal of the value that follows the division sign, and we'll switch the sign from division to multiplied by. Can we cancel anything out? We cannot. Multiply the numerators, multiply the denominators. 9 times 5 is 45, and 4 times 17 is 68. Can we simplify this down? We cannot. This is now the final answer. I would like you to now pause your video and try B on your own. See if you can get the correct answer. I'll take it up afterwards. Let's now take it up. First thing to do, convert your mixed numbers into improper fractions. Eight times 1 is 8, plus 5 is 13. 13 over 8 divided by 2 times 4 is 8, plus 3 is 11 over 4. Now we have our values as improper fractions. Next up, we take the value that comes after the division sign and we take the reciprocal. This gives us 13 over 8 times 4 over 11. Can we cancel out terms? We can. I have an 8, I have a 4. How many times does 4 go into 4? 1 time. How many times does 4 go into 8? 2 times. Multiply the numerators, multiply the denominators. This now gives me 13 over 22. Final answer. Alternatively, you could have multiplied 13 by 4 and 8 by 11, and then you would have had to simplify by dividing the top and the bottom by 4. With canceling, we can speed things along. We can eliminate that extra step, physically having to remove the 4 from the top and the bottom. The last question of the day. I would like you to pause your video and try this one on your own. A student travels a distance of 125.5 kilometers in a time of 1 3/4 hours. What was their average speed? So the formula has been given to you right here. Distance equals velocity times time. Velocity is their speed. So here I have distance, here I have time, and here I have the velocity. This would be the average velocity. I want you to try and solve this one on your own. I want you to see something, what you do to solve this. I have a feeling you've been taught incorrectly. You've been given a trick to try and help you do your math. The problem is this trick has weakened your skills. Give this a try. We'll see if you do that. Final answer here is 71, 5/7 kilometers an hour. Let's see how I got there. Again, we have our time, we have our distance, and here, this is our velocity. For the purposes of this, velocity and speed are the same thing. Hopefully that didn't trip you up. What many of you would have done is you would have done this. Distance equals velocity times time. And then you would have taken the distance right here, and that's right there. And you would have taken the time right here, and that's time right here. And what you would have done is you would have substituted them in. So 125.5 kilometers is equal to velocity times 1 3/4 hours. Remember, we're keeping our units in there. Then you would have rearranged it. V equals, we have V right here. I want it on its own. I'm multiplying by 1 3/4 hours. How do I get rid of that? I divide by 1 3/4 hours. As long as I do it to both sides of the equation, we're going to examine this in more detail in a future lecture very shortly. We have the same thing on the top and the bottom, so they cancel each other out. So here we get velocity is equal to 125.5 kilometers divided by 1 3/4 hours. My advice to you is try and rearrange your equations first. Why is that my advice? When you're rearranging letters, it's easy. When you're rearranging numbers and units, it can be difficult. You can make mistakes transferring your values from one spot to another. So again, my advice is try and rearrange that. Now here's the thing I hate that students bring to class. This stupid triangle. D over VT. If you don't know what this is, I want you to skip over the next 1 minute of this lecture. If you do know what this is, you've been taught how to use this. Whoever taught you this did you no favors. Why is that? Because they've eliminated that need to learn how to rearrange an equation properly. In science, that's extremely important. So let's review how to rearrange this. We have V right here. We want to have that on its own. I can do whatever I want to equation as long as I do the same thing to both sides. I'm multiplying by t, so I do the opposite. I divide both sides by t. These cancel out. We then get velocity equals distance over time. And you can see that's how we get that solved. So please, please, please don't use this ever. It may help you get through first semester courses, but as we get to more complex equations, it's not going to help you. So just delete that from your mind if possible. Let's solve this now. What does this mean? Let's rearrange it. 125.5 kilometers divided by 1 3/4 hours. What's the first thing we want to do when we have mixed numbers? Convert them to improper fractions. 125 times 2 plus 1 over 2 kilometers. Divide that by 1 times 4 plus 3 over 4 hours. Next up, 125 times 2, 250, plus 1, 251 over 2. Be careful of that. I've seen many students, they will just do this part here, and they forget to include this part. Make sure you do it all. Kilometers. Over here, divide that by 1 times 4 is 4, plus 3 is 7 over 4 hours. What's next now? Let's copy this one down as is. We're going to take the value that comes after the division sign, and we're going to take the reciprocal of the value. Change that to a multiplication sign. 4 over 7. What do I do with the hours now? The hours, let's turn that into a fraction. Hours over 1. We take the reciprocal of that as well. Be careful of that. We then multiply our numerators, and we multiply our denominators. And let's include those units there. Technically, this would also be a fraction over 1. Can I simplify anything? I sure can. A 2 on the bottom and a 4 on the top makes that a 2. This now gives me 251 times 2 is 502. And don't forget to multiply this as well. And over here, over 7. Notice what happens with my units here. Kilometers on the top and hours on the bottom. This is a improper fraction. Let's turn that into a mixed number. How many times does 7 go into 502? Long division now. That's going to be 7. 49, 1, bring that down 2. It's going to be 1, 7. We have 5 remaining. So in the end here, this becomes whole number 71. Denominator remains the same. And our remainder from there goes up top. And our units is kilometers over hours. Kilometers per hour. So the purpose of this was twofold. Number 1, make sure you learn to rearrange equations without using that silly triangle. Number 2, the rules apply not just to the numbers, but to the units as well. Don't forget that. Therefore, the average speed was 71, 5 over 7 kilometers per hour. Remember, that's your speed. When you're driving in a vehicle, you look at the speedometer. What's the units? Here in Canada, it's kilometers per hour. I can't stress this enough. Rearranging the equation is a key skill to master. You need to know that. Make sure you spend some time studying that if you have a difficulty with that. That's all for today. I hope you enjoyed learning about dividing of fractions. We're going to use it quite a bit in the future. Until next time.